Okay, today we're going to talk about rational expressions. So rational, just pretty much a fancy name for a fraction. So a rational expression is a over b, where a and b are actually polynomials. But clearly, you have a fraction, your denominator cannot equal to 0. That'll be our restrictions. So the domain, or the values for which the expression is defined. So example of a domain, find the domain is any value for x, all real numbers, except what makes the denominator 0. And what is that? X cannot equal to -5. So if we want to write that in interval notation, think about our number line, and we have to take out -5, delete it. So it's everything to the left, everything to the right. So it's minus infinity all the way up to -5. We don't include it, union to the right. We include it, don't include it on the left either. So when we are simplifying, there's basically just two steps. You have to factor everything. We factor the numerator and the denominator. The reason you factor is because we cancel factors. And we do not cancel terms. Okay, the terms are the ones that are separated by the pluses and minuses, so we only you have to factor it and cancel exact factors. So think about simplifying fractions. If I have 6 over 15, in order to simplify that, we know there's a 3 that divides top and bottom, but it's a factor of 3. 3 times 2, 3 times 5, and the 3 cancels top and bottom, and that's exactly how we're going to simplify rational expressions. So let's look at an example. So what I mean by not canceling terms, this is a term and this is a term, and you cannot cancel those two, okay? So what we do is we factor. The top only has a 2 in common, so we factor out a 2 from the top. There's a 2 in common in the denominator, so we factor out from the denominator, and then the 2's cancel, and my answer that is left is x plus 1 all over 2x plus 1. So as I mentioned, we want to find our domain first, even though I didn't ask for it, because if it cancels, we still have to include that as a restriction. So to find our restrictions, let's factor the bottom, the denominator first. So 3x and x. It's going to be 8 and 3, maybe. You don't want to put a 3 here because it would have a 3 in common if it went there. So we're going to put the 3 there and the 8 there. And this is 8x, 9x. We need a plus 9x and a minus 24. That works. So our restriction, we'll just state our restriction first. Restrictions, x cannot equal to -3 and 8/3. Those are our two restrictions. So my domain, again, if it's easier to graph it really quick, so you can, this is -3, 8/3. It's everything but those. So my domain is minus infinity to -3 union -3 to 8/3 union last one 8/3 to infinity. So there's my domain. And now to simplify. So to simplify, you factor the numerator and the denominator. because we have the 3 and 11 here. 2x, x. Since we hope for it to simplify, I'm going to guess plus 3 and 11 here. And let's check, that's 11x and 6x. It looks like we can cancel these two factors, and it simplifies to is my final simplified answer. So what we're going to do is we're going to, the top is already factored, so we're going to factor the bottom, and it's just difference of squared, a plus b, a minus b, and we can see we can only factor exact factors, and b minus a and a minus b aren't exactly the same, but we could make them the same by, if I, on b minus a, if I factor out a negative, I get minus b. I'm basically taking the opposite of each sign, plus a. When I distribute it, it's positive b minus a, and that becomes minus 1 times a minus b. So we can factor out a negative from the top, and what's going to happen is now we have exactly the same thing. It's left by a negative 1. Think about it that way. So there's nothing left on top. So it's minus 1 on top and a plus b on the bottom. And that's our final answer. You know, just to a little bit more insight onto this, if I think about the b minus a all over a minus b, all it is if I just throw in two numbers, like let's say 5 and 3, right? So if we have 5 minus 3 all over 3 minus 5, that's all it is. It's backwards, right? So 5 minus 3 is 2, 3 minus 5 is minus 2, and then they're the same difference, but one of them's negative. So basically, those are always canceled to be a negative 1. Put it on the top of the bottom, of course. So you can do that. You know, just see that they're the opposites and replace it with a negative 1, or do the work here and factor out a negative. It's the same difference. So now I'm going to move to multiplying. Multiplying is going to be the same thing. So I actually have 3 fractions to multiply here. But remember, when you multiply across, so you can cancel top and bottom anywhere, because it's just one big fraction. We can make this one big fraction like so, but we want to make sure we factor these if they need factoring. So x squared minus 3x plus 2 is going to be 2 binomials. It's x, 2, 1, minus will give me my minus 3x. The minus 3x, the 3x is there. The 2x plus 4, we have a 2 in common, so I'm going to factor out that 2, x plus 2, and then we're going to factor the bottom. X plus 2 is there, it's already factored. X minus 2, just so you can see where we're going, this is there. And this last one, x squared minus 5x, has an x in common. And so now, we don't need to highlight that, but just so you can see, I just multiplied everything across, but I'm not multiplying, I'm factoring. And then we can cancel anything that's the same factor on top. X plus 2 there, x plus 2 there. X minus 2 there, x minus 2 there. And that's it. Oh wait, there's an x here and an x there. And now, looks like we're done. What are we left with? We're left with the 2x minus 1 on the top, and 2 times 3 actually. 2 times 3 is 6, and an x minus 5 on the bottom. And we can leave it like that, or distribute the 6, it doesn't matter. Now dividing, you have a over b divided by c over d. We can rewrite this by dividing. Instead of dividing, we multiply by the reciprocal. And then, of course, we can multiply across. That's how we multiply. Okay, and there's nothing to cancel there, obviously. So we just turn dividing into multiplying and multiplying into simplifying. So let's do one. So here's our first problem for dividing, and it could actually say divide or simplify. Both instructions are appropriate. So again, if we want to just do one step at a time, let's not get it confused. We change the divide to times, and we flip what we're dividing by. So this up here got flipped. So it's x squared plus x on top, x to the third minus 5x squared on the bottom. We just copy this first one, and this is equal. And now we can factor everything. X plus 5, x minus 5, all over x times, I'm going to factor out an x plus 1 is left. We have an x squared, you take the smallest power, x squared in common, and then we have x minus 5. So now we can simplify, and I just want to remind you, we can simplify each fraction. Like I can cancel this x with one of those, or if I like, I can cancel across this times, this one with that one can cancel, just like this x minus 5 can cancel down across the times. And what are we left with? We're left with x plus 5, x plus 1 all over x squared, and we can keep it factored like that. Okay, so here's one more for dividing. So first we're going to flip and multiply. So this changes to times, so we flip what we're dividing by, and it's 1 minus 4x squared on the top. On the bottom is 2x plus 1 quantity squared. Here I'll just copy, and I'll copy. Okay, so now factor, factor, factor. First is a trinomial, factors into two binomials. And this 4x minus 2 has a 2 in common, so it's 2x minus 1. Here it's 2x, x, 1 and 1, we're kind of forced. One's a plus, one's a minus, it doesn't matter. We want a negative x, so the negative 2x will have to go there. And over here, the top, 1 minus 4x squared is actually a perfect squared is 1, and a 4x squared is a perfect squared, so this is difference of squares, 1 plus 2x, 1 minus 2x. And on the bottom, 2x plus 1. If you want to write it out twice, or you can just cancel the powers, it doesn't matter. So let's see here, 2x plus 1, we can cancel across that times, top and bottom though. 1 plus 2x, 2x plus 1, since it's plus, they are the same thing, the order doesn't matter on the plus. And then here, 2x minus 1, 1 minus 2x, they're the same but opposite, so remember it cancels and leaves a minus 1. So don't forget about that minus 1, or you could rewrite it, factor out a negative and so forth. So that's all that cancels. I'm left with a negative 1 on top. I'm left with a negative 1 times x minus 1 on top. On the bottom looks like a 2. And if you want, we can distribute that negative. Remember, when you distribute a negative, it just flips the sign. So it's negative x plus 1, or 1 minus x all over 2. You can even distribute the 2 if you want. Monomial division, 1/2 minus x over 2. But that looks nicer. So either answer, though. It's or. Okay, that's how you simplify and multiply and divide rational numbers. If you want to know how to add and subtract rationals, there's a link to my next video in the description. Thanks.